What could possibly go wrong when we intentionally collide a spacecraft with an asteroid? Have you ever thought about it? It's a fascinating question, isn't it? This isn't a plot from a science fiction movie, but a real mission called DART, or Double Asteroid Redirection Test, launched by NASA. The mission's target? An asteroid called Dimorphos. In an audacious experiment in September of 2022, NASA aimed to change the course of Dimorphos by crashing a spacecraft into it. The purpose was to investigate whether we could deflect an asteroid's path to potentially avoid a future cataclysmic collision with our planet. Sounds pretty incredible, right? Well, the mission was successful. The spacecraft's impact altered Dimorphos's orbit around its larger companion, Didymos, by a significant 32 minutes. But it wasn't just the asteroid's path that changed. The impact resulted in a substantial alteration of the asteroid's shape, causing an 8% change in its mass distribution. However, this cosmic car crash had some unexpected consequences. The collision ejected a staggering amount of material from the asteroid, between 13 and 22 million kilograms to be exact. That's roughly 0.3 to 0.5% of Dimorphos's entire mass. Remarkably, this debris included 37 boulders, some as large as 22 feet across. As Andy Rivkin, an astronomer from the DART team, admitted, "We did not expect that many boulders that were that big to be blown off." But where does all this debris go? Unfortunately, it doesn't just disappear. It's sent flying into space, and some of it could potentially cross paths with Mars. So while the mission was a success in terms of altering an asteroid's path, it might also have set the stage for an unintended cosmic bowling game with Mars as the potential strike zone. So we managed to change the path of an asteroid, but at what potential cost? As we continue to venture into the realm of asteroid deflection, we must also consider the unexpected consequences that such actions might bring. Now, Mars may find itself in the crosshairs of the DART mission's unintended fallout. After the DART mission's successful collision with Dimorphos, a surprising amount of material was ejected from the asteroid, an estimated 1.3 to 2.2 x 10 to the power of 7 kilograms to be precise. This ejection resulted in an 8% change in Dimorphos's mass distribution, radically reshaping its form. Among the debris were 37 boulders, some as large as 22 feet across. This asteroid debris, now hurtling through space, might not be as benign as we first thought. According to a study by Johns Hopkins Applied Physics Laboratory and the DART team, some of these ejected rocks may collide with Mars in the distant future. So, how can we predict such a future collision? This is where the concept of minimum orbit intersection distance, or MOID, comes into play. MOID is a measure of the closest distance that two orbiting bodies can approach each other without an outside force altering their paths. In this case, the MOID between the ejected material and Mars will be extremely small on 4 separate occasions, twice around 6,000 years from now, and twice more about 15,000 years later. But what would happen if these rocks do hit Mars? The researchers suggest 2 possibilities. Some of the rocks may burn up in Mars's thin atmosphere, while others could collide with the planet's surface, creating a significant impact crater. Given the sparseness of Mars's atmosphere, it's likely that the boulders will reach the ground intact, excavating a small impact crater. This potential fallout from the DART mission underscores the importance of monitoring ejected material from asteroid deflection missions. While the debris from this mission poses no immediate threat to Earth, we must consider the potential consequences for other celestial bodies in our solar system, like Mars. Mars might be bracing for a shower of asteroid debris, all thanks to our asteroid deflection experiment. As we continue to explore and understand our universe, let's remember that every action, even those aimed at protecting our planet, can have far-reaching consequences. But this isn't just about Mars. The consequences of asteroid deflection missions hit closer to home than you might think. You see, when we talk about altering the course of an asteroid, we often overlook one crucial aspect: the ejecta. That's the debris, the cosmic rubble that gets flung into space following the impact. And monitoring this ejecta is more important than you might initially believe. Picture this: a spacecraft smashes into an asteroid, successfully altering its course. A victory for humanity, right? But hold on a second, what about the debris that's been ejected into space? That's a whole new can of cosmic worms. This debris, these boulders, aren't just drifting harmlessly away. They're on the move, potentially on a collision course with other celestial bodies. And yes, that includes our beloved Earth. Here's where things get even more interesting. The recent DART mission, while a resounding success, led to the ejection of an estimated 13 to 22 million kilograms of material. That's up to 0.5% of the entire mass of the asteroid. And among this ejecta were 37 sizable boulders, some as large as 22 feet across. Now many of these boulders are predicted to pass close to Earth, albeit in the distant future. But what if our calculations are off? What if these space rocks pose a more immediate threat? That's why monitoring the ejecta is so critical. But it's not just about our home planet. If we're serious about becoming a multiplanetary species, we need to think about future human settlements on Mars as well. The red planet, with its thin atmosphere, offers some protection against smaller objects. However, larger space debris could potentially cause significant damage. Stefania Soldini, a space engineering expert, emphasizes this point. She argues that we must closely monitor any ejecta resulting from asteroid deflection missions. This isn't just a theoretical exercise, it's a necessary step to safeguard our planet and future human settlements. So it's not just about changing the course of an asteroid. We need to be prepared for what comes after. And there's more. This study also sheds light on another intriguing space mystery. You see, as we walk the Earth, we might stumble upon a peculiar rock, a meteorite. These extraterrestrial objects have been the subject of fascination and scientific study due to their origins beyond our planet. But where exactly do they come from? The researchers behind the DART mission study have provided us with a compelling answer. They suggest that some meteorites found on Earth may have originated from collisions between near-Earth asteroids and smaller projectiles. Imagine this. An asteroid, about the size of a football field, is peacefully floating in space. Suddenly, a smaller object, maybe the size of a compact car, smashes into it. The impact is colossal, hurling debris into space. Over time, and after a journey that could last thousands of years, some of these fragments survive their fiery descent through Earth's atmosphere and land as meteorites. This revelation not only deepens our understanding of meteorites but also offers a glimpse into the violent and dynamic processes that occur in the vast expanse of space. It's a stark reminder of how everything in the universe is interconnected, and how events happening millions of miles away can have tangible effects right here on Earth. Moreover, this finding underscores the importance of missions like DART. By studying the aftermath of deliberate asteroid impacts, we can better understand natural collisions and their outcomes, which in turn helps us decipher the stories that meteorites carry with them from the depths of space. The universe is indeed a cosmic jigsaw puzzle, and each meteorite is a piece that helps us see the big picture. They tell us about their parent asteroids, the collisions they've been through, and the immense journeys they've undertaken to reach us. So the next time you see a shooting star, remember it might just be a piece of an asteroid that we've nudged. So, what have we learned from all this? In our quest to protect our planet, we've embarked on daring missions like NASA's DART, which successfully deflected an asteroid's path. However, this triumph of human innovation had some unexpected results. In the process, a staggering amount of material was ejected from the asteroid Dimorphos, altering its shape and mass distribution significantly. While none of these ejected boulders pose a threat to Earth, Mars might not be so lucky. Researchers have predicted that some of these rocks may collide with the red planet in the distant future. This highlights the critical importance of monitoring such ejecta, as it may pose a risk to our celestial neighbors and future human settlements in space. Moreover, the study also offers insight into the origin of some meteorites found on Earth, suggesting they may have resulted from similar asteroid collisions. As we venture further into space, it's clear that even our best intentions can have unexpected consequences, and as we've seen, those consequences can reach as far as Mars.